Shri Gurubhyo Namaha. Shall we learn something very interesting about rational numbers today? Ratio of two numbers. A lot of kids have asked me this question, about 30 children to be precise, in the last few days. What is rational numbers? What is a ratio and why are certain numbers called rational numbers? So we're going to start with simplest operations of plus, minus, multiply and divide. Fundamental operations, right? If it is a plus, you start with number line 0 and you just go one at a time. 2, 3, 4, you just go one at a time in the positive direction. Subtraction is you go in the reverse direction. What is multiplication? You jump at least twice or thrice in every time you go. Like if you go twice, you jump 3 times, you will end up in 6. 0 to 6. So 3 into 2 is 6. So jump counting is multiplication. Reverse going back one at a time is subtraction. Forward is addition. And what is division then? It is equal grouping. If we take 6 things, divide it into 2 equal parts, you will get 3 in each set. That is called division. Dividing is nothing but equal groups. So in such a case, we know this gives you a rational number. What is called as a rational number? When it is a ratio of two numbers, it becomes a rational number. Let's say 10 divided by 5. It is 2.0. You call it 2 or you can call it 2.0. 10 divided by 5 is 2. So 0 is not necessary, so you call it as 2. This is the first case of a rational number where the decimal is not needed. 10 by 5 is 2. I'm going to do it the other way now. 5 by 10 is 0.5. So here there is a decimal, but this decimal finished. Second case, it finished. It didn't go all the way, but it finished. Let's do 1 by 4. If we do 1 by 4, it is 0.25. This decimal also finished, but just not one number, but two numbers. Like this, there might be 3 numbers, 4 numbers. If it is 1 by 8, it might go to 3 numbers and finish. These are all finishing numbers. Finishing number category, also called as rational numbers. First is no decimal, rational number. Second is decimal, but it finished. What is the third category? 1 by 3. This number can just go on forever. 3, 3, 3, 3, 3. It can go up to infinity forever and never terminate. Similarly, 1 by 6, 0. If you put 0.10, so it is 1, followed by 40, so that is 6, 40, 6, 40, 6, 46. What am I doing? I'm storing the remainder in my brain so that I can calculate how it is. If I put 0. The moment I put 3 here, it's a quotient, and I'm remembering the remainder in the background of my mind. So remainder is very, very important game that we're going to play today. It's called a remainder or remainder, right? That is how 0.160, so 66666. This is what happens. Now, I'm going to give you a new case of fourth case. First case, no decimal at all. Quotient completes. Next, second case, there is a remainder which also gives you decimal numbers. And the third one is you have infinite numbers, but never completes, but only one number is repeating. Here, repetition happens. So now I'm going to tell you about the fourth case, right? I told you. What is this fourth case? Where some of the decimal numbers will repeat in a very fancy way. We're going to see how. Let's take 1 by 7. It is 0. And I do remainder immediately. My remainder is 10. Therefore, it is 1 here. If I put 1 here, it is again 30. So it is 4. Check with me. 2, 8, 5, 7, again 1, 4, 2, 8, 5, 7, again 1, 4, 2, 8, 5, 7, goes up to infinity. This thing repeats again and again. Why is this repeating? Why is this pattern repeating? Is because There are only limited set of reminders possible when you take the number 7. You could have a remainder of 0 where you divided it perfectly, or you could have 1, or you could have 2, or you could have 3, or you could have 4, 5, 6. Is 7 possible? No. 7 can never be a remainder when you have 7. So only these numbers are possible. So if you keep it in the mind, you will see that the pattern is repeating. Even if you get 1, first was 1 was a reminder, second time 3 was the reminder. So it goes on like that and then it comes back to 1. That is the magic of this repeating pattern, right? So this category is also called as a rational number, and this applies to, like, let's say 22 by 7. 22 by 7, people say it is pi. It is not pi. It is also rational number. Pi is a special number. We'll talk about it later. 22 by 7 is 3 point, again reminder is 1, so therefore 142857, 142857 repeats. The same pattern is repeating because you have the same denominator, the same reminder as 1 here, because 7 3s are 21. Same thing repeats. So these are called rational numbers. So you would have repeating patterns after the decimal, or one number only repeating throughout, or you could have terminating decimal or no decimal at all. Did you learn something new today?